Hi, this is Mrs. McGrath. This video is going to tell you about standard form, how to graph in standard form, and particularly how to write equations in standard form. We will also touch upon some applications with standard form. This can get a little bit tricky, so we're going to focus on those more so tomorrow in class. Just remember to bring 1 page of notes to tomorrow's class. Previously, we could have asked you to graph the following line. In order to graph this, you would have had to make it look like y equals mx plus b by isolating your y value. This takes a little bit of work. You would subtract x from each side. We'd get negative 3y equals minus x plus 6. You'd then have to divide by negative 3, and you'd end up with a positive 1/3 x minus 2, which, if we were to graph, we have a y-intercept of negative 2, and we have a slope of 1/3. Now, this is not the most efficient method. Another method is using standard form. Standard form is an equation that looks like ax plus by equals c, where a, b, and c are just numbers. Our line has an a value of 1 because there's no number there, a b value of negative 3, and a c value of 6. In order to graph this, you would first want to find the x and y intercepts. The x-intercept, just as a little refresher, occurs when y is 0, where your y-intercept occurs where x equals 0. That is always the case for a line. So, solving for our x-intercept, we're going to have x minus 3 times a y value of 0 equals 6. This will give me an x value of 6. For our y-intercepts, x is 0, and we're going to have to solve for y. Algebraically dividing both sides by negative 3, we'll end up with y equals negative 2. In order to graph this, we are going to plot the intercepts and connect them. So on your graph, when x is 6, y is 0. It's this point right here when x is 6 and y is 0. And over here, for our y-intercepts, we have x is 0 and y is negative 2. And then you can just connect the two. So example 2 is in standard form, where a is 1, b is negative 4, and c is 8. In order to graph, we've got to find our two intercepts. I'm going to first start with the y-intercept, where x is 0. So I have 0 minus 4y equals 8. Therefore, y would end up equaling negative 2. For our x-intercept, y is 0, so we'd have x minus 4 times 0 equals 8, or x equals 8, which we were able to come up with quite easily. I'm going to shrink this and draw a coordinate grid, and we have 2 points. We have one point where x is 0 and y is negative 2, right here, with our y-intercept, and we have our other point where x is 8 and y is 0. Connecting, we have a line with positive slope. I'm going to leave you to do example 3 in your notes. As we discussed, standard form looks like ax plus by equals c. In order to get equations to look like this, you want to get your x and your y term on the same side of the equation. As there is a requirement that a, b, and c have to be integers, you're going to want to clear any fractions by multiplying by the common denominator. As a decimal is the same thing as a fraction, you can clear them by multiplying by 10 or 100 or 1,000. The final step is that a, b, and c must be the least common multiple. Here are 4 examples. I want you to take down number 1 and number 4, which I'm going to do here now in your notes, but I also want you to try number 2 and number 3 in your notes alone as well. So in number 1, in order to change this to standard form, remember that the first step is to get x and y on the exact same side. So we have to move our 3y over. To do so, I'm going to subtract 3y from either side. This is going to give me 2x minus 3y equals 8. I'm going to check this to see if there are any fractions, which there are not, as well. There's no decimals, so I'm fine on that end. In addition, the least common multiple is 1. There's nothing I can divide by, so I am fully reduced, and that is my answer in standard form. I'm now going to take a look at number 4. We have some decimals, and if you take a look at the left side, each of these have 1 decimal place, so I could multiply by 10, but if I take a look at the right side, if I multiply by 10, I'd get 4.6. Would not be sufficient, so instead I actually have to multiply by 100 since I have 2 decimal places. What I do to one side, I'm going to have to do to the other side. This is going to yield 46 on the right side of the equation. Remember, when you multiply by 100, it moves the decimal place 2 spots, so I will actually get 120x, and the 2.4 will become 240y. Now, I'm taking a look at this. The decimals are gone. However, I'm noticing that all of these are actually divisible by 2. In order to make the LCM 1, I'm going to have to do that because I can reduce this. So I divide each side by 2. On my left side, I'm then going to get 60x plus 120y is equal to 23. These two are multiples of 2, but 23 is not a multiple of 2. Therefore, I have my final answer. So go ahead and try number 2 and number 3 on your own. I will check these tomorrow. Here's an old word problem that you could have seen on our last quiz or what we've been doing. Really what's happening in this particular case is that I'm giving you 2 points. In this problem, Mrs. Ferguson has decided to open a business making fleece blankets. She's going to charge $20 for 3 blankets, $36 for 5 blankets, and we want you to write an equation that represents the cost in terms of the number of blankets. So here's our first point, where 3 blankets, as long as I had x is equal to the number of blankets, the y value, or the cost, is $20. In addition, our second point is right here, where we have 5, $36. Given 2 points, you guys do know how to come up with an equation that looks like y equals mx plus b. However, you're now going to focus on totally different types of word problems. So don't write this one down in your notes. Just recall that we've done problems like this. Here's our new type of word problem. It still does represent a line, but in this case we're not given 2 points. Here we're selling candy bars to raise money for the track team, and candy bars are sold at 2 different prices. The first price is $3 per candy bar for students. The second price is $4 per candy bar for the adults. The goal is to raise $24. So the first thing that I would like you to do is define your variables. If we think about this, we want to know how many bars we're going to have to sell to the students as well as to the adults. So I'm going to let x equal the number of candy bars sold to students and I will let y equal the number of candy bars sold to adults. These notches just means it's the same words as above. So we've defined the variables. The next thing we need to do is we need to write an equation that models the situation. The amount of money that's going to come in from the candy bars sold to the students is going to be $3 times the amount of candy bars sold to students. So if we sold 1 candy bar, we'd get 3. If we sold 2 candy bars, we'd get $6, 3 candy bars, $9, etc. The amount of money that comes in for the adults is going to be $4 times the amount of candy bars sold to them. For example, 1 candy bar, we would get $4. 2 candy bars, we would end up with $8. 3 candy bars, we'd end up with $12. Now, we want to raise a total of $24, so to account for this total, we are going to sum up the money and we want it to exactly equal 24. If we take a look at this, we can now see why this is a standard equation, or an equation in standard form, excuse me. So we have written an equation to model the situation, and now we need to graph it. In order to graph it, remember you're going to focus on your x-intercept as well as your y-intercept. Your x-intercept is going to occur when y is 0. So if y is 0, we will end up with an equation that 3x is equal to 24 because the y term drops out. This is going to give me an x value of 8. So if I go over to my axis, 1, 2, 3, 4, 5, 6, 8, looks like we have a point right here. So when x is 8, y is 0. Our y-intercept occurs when x is 0. Notice that they're always opposite. And in this particular case, if x is 0, we have the equation for y equals 24, or y is equal to 6. So when x is 0, y is 6. 1, 2, 3, 4, 5, 6. I have a point right here. I'm going to label that as 6. We should also label our axes where we have x and y. And in order to graph our equation, we connect the dots as we did previously. This question can actually get quite tricky. We're going to address it tomorrow, so don't worry about it, but I would get down your equation and the steps to find the intercepts and everything else. And we will focus on more applications tomorrow. They are definitely very, very tricky.